Starting with the release of the 2012 version, ASAP has a new technique for dealing with rays that are incident upon a scattering surface beyond the critical angle. Previously, in this instance, the rays were functionally treated as undergoing the TIR an infinitesimal distance in front of the surface. Therefore, if the surface had a texture or roughness to it, the rays never saw that effect, and therefore all of the energy was TIR'd back into the dense media. With ASAP 2012, you can apply a scatter model to one of these surfaces, just as you have in the past. But in this instance, what ASAP will do is analyze the rays statistically to determine what the likelihood is of the ray actually reaching that surface due to the surface texture at an angle less than the critical angle. And if this is the case, those rays will be allowed to transmit out through that interface. Additionally, the light that reflects back into the denser media will either simply TIR due to the surface property in the angle of incidence, or it could also scatter in the reflected direction depending upon the properties of the particular scatter model that's applied. In this case, what you'll see is a system that just consists of a plate of glass, and on the second surface of the material, I've applied a simple Lambertian scatter. And then what we're going to do is generate some scattered rays within a 10-degree cone about the specular angle relative to the ray at the point of intersection. For my source, I've defined a simple pencil of light of several rays that are going to start within the glass media. Notice that the rays are incident at an angle of 45 degrees, which is beyond the critical angle for these rays in the media. And again, statistically, ASAP will determine what the likelihood of the rays are of being either scattered and transmitted, scattered and reflected, or simply TIR based upon a statistical analysis. I've already run the simulation, so let's take a look at the output plot. You'll notice again, here is my plate of glass. Here is my source, starting within the media. And again, you'll notice the 45-degree angle being beyond the critical angle, and that much of the energy transmits through, and that some of the energy goes back in reflection. And let me zoom in a little bit and we can take a look. So what we see are these rays coming in, and again with a Lambertian scatter relative to the angle coming in. Much of the energy was transmitted out, but you'll notice the ray angles are different simply because they have that Lambertian distribution. Now, of the light that gets reflected back into the plate, some of that light will go in the specular direction because it is beyond the critical angle, but also due to the surface properties, it is possible that the reflected light will also scatter. So what we see in ASAP 2012 now is the ability to more accurately model the physics of your systems when you have light incident on roughened surfaces.